Hi everybody, we are going to talk about the prediction of compressive stress strain curves of grouted masonry article. This article talks about grouted masonry and the influence of mortar on them. We are going to study the constitutive law and see how are the curves of strain compressive in that grouted masonry. All blocks used in this study were all prepared in the laboratory. The block is 190 millimeters in height, 190 millimeters in width, and 200 millimeters in thickness. How you can see the mechanical element on this grouted masonry. According to that, we can see the proportion of materials. They establish groups called A1, A3, B1, B3, C1, C3, and we can see there are concrete of block, cement, mixed by sand, gravel, and water. They are the relations. The relations. Also, we can see the ground mixed by cement, sand, gravel, and water, and mortar mixed by cement, sand, lime, and water. In Table 1 and Table 2, we can see the material properties and the reference of the materials. This is the table of compressive strength of tested prisms. The compressive strength was computed using the gross area, which was 78,000 millimeters square. You can see in Figure 3 the compressive strength of tested ground prisms. They tell us as the strain of blocks on mortar are basically at the same level, test results appear to increase linearly with the compressive strength of grout. We can see that in the figure 3, how is the according to the points, the tendency of lineal. Figure 4 show the measured strain curves, and the corresponding strain compressive strength is found to be less than 0.002, according to Presley's constitutive law. In Figure 4, A, B, C measured strain curves of A group, B group, and C group corresponding. The compressive constitutive law. Concrete softness theory. In this paper, the model proposed by Su et al. Is used as the basic analysis theory, as shown in equation for strength strain. Influence of mortar. In the previous discussion, the compressive strength of prisms appears to increase with the compressive strength of grout. Moreover, the compressive strength of the prisms increases with the compressive strength of the block has also been confirmed in other research results. The following assumptions are used to establish the analysis model. The strength ratio is within the ideal range. Failure of the web causes the failure of grout masonry. The block element is in the tension compressive strength state and the strength is biaxial, shown in figure C6b. We can see the stress-strain curves. In figure 8, show that with decrease of lime mass, the new curve is closer to the original. Comparison of prediction compressive stress-strain curves, tests, and in the origin. Conclusions. Examination of existing experimental results and calculation results of the literature equations indicate that the I-type mechanical element is capable of predicting the compressive behavior of grout masonry. The proposed model achieves a satisfactory result in the prediction of compressive strengths and elastic models. The average ratio of M tests is 1 with COV of 0.17. The proposed model is based on the theoretical research results, which makes this model have good applicability and modifiability. With the support of the reality theory, different constitutive laws and deformation ratios can be used to modify the proposed model within the theoretical frame of this paper, so that the model can be applied to some special case beyond the scope of this paper. Thank you.